For a second, everybody. You have dv dt, you want dd, but the key trick here, the thing that made this slightly tricky, is that your formula is in terms of radius. You could transfer it though. For example, you know that volume is equal to, of the sphere, 4/3 pi r cubed, right? What does radius equal in terms of diameter? Diameter over 2. So what could you do with this? You can plug it in and you get volume is equal to 4/3 pi times d over 2 cubed. Simplified a little bit, and you end up with volume is equal to, it's going to be 1 over 8. So it's going to be what, 2/3 pi d cubed. Why did I get 2/3 right there? Is that right? No.
No.
Times 8. It's going to be 8, 1/2, 6, right? And it's 1, is it 1/6? 4/3 times 1 over 8 is equal to 4 over 24 is equal to 1 over 6. I'm just doing the basic algebra, kids. So look, that right there, what is that? That's volume just in terms of diameter. So you could start that way instead if you wanted to. You could start that way instead if you wanted to. You're going to have to do a substitution in parts. The only thing you need to remember to the equation for the volume. Got to use a lot of words here, more than just a couple. So what do you know the volume of the cone is going to be? 1/3 times pi times what is r?
2
over
5
squared times h. Let's clean that up a little bit. That turns into 4 over what? 4 over what?
15.
5 squared times 3 is 75. So that is the volume just in terms of h. At this point, we can differentiate with respect to t, time. So dv dt is going to equal what? 12 over 75 pi h to what power?
2.
Times dh dt. Which one are we solving for?
DHDT.
We're solving for dh dt right there. So we need to plug in values for everything else. Do we know what dv dt is? What is it?
5.
5 equals 72 over 75 pi 75. I'm sorry, what?
12.
So it is 5 over 4 pi. So once again, the key thing here, the most important thing that most people miss, the most important thing is this right here. Start with that, and then what do you get? You get a nice formula right here. You get this nice formula right here, which is really easy to deal with. Can you just take the derivative at the beginning if you want to? You can, but what would you have to use, Molly?
The product.
You'd have to use the product rule. And does that make it a little bit more big and nasty? Yeah, you want to avoid that. This is very similar to what we did before. Before we wanted the rate of change of the diameter, but we had everything in terms of the radius. It was a really simple substitution. Again, is it a pretty simple substitution? Yeah, it does totally rely on your memory of similar triangles.